Hey everyone, welcome back to another lesson in MCV4U. Today we'll be talking about a review of log laws. So if you recall, if it tells you to rewrite this in exponential form here we have y is equal to log x. And here if we want to rewrite it as an exponent, we know that here value of y will be the exponent. We know that if there is no base that is written, we can assume that the base is going to be 10. So here we'll write that this is the base, and then whatever is multiplied by the log value is going to be our answer. So here, if we rewrite this as an exponent, we can rewrite it as the base is 10 to the exponent, which here it would be y, is equal to x. So again, 10 being the base, y being the exponent, and then x being the answer. And so important here to also recognize, again, that b to the power of log base b x is equal to x. So it's just an important thing to understand here. And there's two laws that for logs that are important. So log base b of m times n is equal to log base b of m plus log base b of n. That would be called the product rule. And also when we look at the quotient rule, we see that log base b of m over n is equal to log base b of m minus log base b of n. And so here, if we see again that if we have a common base, so if we have common base, so if we have log base b, for example, log base b of b to the power of n, we see here that it would simply be equal to just n. Okay, so let's evaluate this here. So here we have log base 3 of 18 plus log base 3 over 2. So here we can rewrite it as log base 3, 18 times 3 over 2. This is the product law. So here we'll have log base 3, 27. Here we can rewrite it as log base 3, 3 to the power of 3. So log base 3 to 3, log base 3 of 3, that will cancel out, and that will just give us an answer of 3. Okay, let's look at this. Let's look at this next one here. So here we have log base 5 of 200 minus log base 5 of 8. So here, again, we can rewrite it as log base 5, 200 divided by 8. That'll give us log base 5 of 25. Can rewrite the 25 as equal to log base 5 of 5 squared, which will simply just give us 2. So here, again, it says to write log base 20 as Sum or difference of logarithms, simplify if possible. So here, again, we can rewrite this. And again, when there's nothing written in the log as a base, we assume that the log base is 10. So here we can rewrite it as log base 10 of 20. And here, so we know that it is equal to log base 10, 10 times 2. So here again, using the product root law, we can rewrite it as log base 10 of 10 to the power of 1 plus log base 2. And here, log base 10 of 10 is equal to 1. And we add that to log 2. Okay, another law that is important in terms of logarithms is if here we have log base b of x to the power of n. Here we can bring, again, it's the same thing if we bring down the n to the front and rewrite it as n log base b x. Here again, b has to be greater than 0. B cannot be 1. X has to be greater than 0. And n has to be an element here of real numbers. So here, if we're evaluating this, we have log base 3 of 9 to the power of 4. So here, again, bring again the 4 to the front. So we can rewrite this as 4 log base 3 of 9. Here we can rewrite it as 4 log base 3, 3 squared, log base 3 of 3. That cancels out. It gives us 1. And so here we'll have 4 times 2, which will equal to 8. In B, we have log base 2, 8 to the power of 5. Here again, we're going to bring down the 5 to give us 5 log base 2, 8. Here we can rewrite it as 5 log base 2 to the power of 3, which will leave us with 5 times 3, which is 15. Here, if we look at this, we have log base 5, square root 125. And we can rewrite the square root 125 as 125 to the power of 1/2. That's what we'll do here. So log base 5, 125 to the power 1/2 here. Now using the power law, we can bring down the 1/2. So 1/2 log base 5. And here we'll rewrite 125 as 5 to the power of 3. So here we'll be left with 1 over 2 times 3, which will give us 3 over 2. Here we have log base 12 plus log base 7 minus log base 3. And here, so again, we can add the two, we can add 12 and we can have the log base 12 plus log base 7, which will be log base 12 times 7 and then over 3. And again, here all the bases are the same, which is why we can do that in this situation. So here we can rewrite it as log base 12 times 7 over 3, just equal to log 28. Okay, let's continue here. Here we can write it as, so here we have 2 log 5 plus 1 over 2 log 16. Here, if we use power law, if we reverse the power law, so here we can move the 2 up and move the 1 over 2 up as well. Then we can rewrite it as log base 10, 5 to the power of 2 plus log base 10, 16 to the power of 1 over 2. Here, if we calculate that, it'll be log of 25 plus log 4. So here we can rewrite that using, again, our product law. So it'll be log of 25 times 4, which will equal to log 100. Log 100 is equal to 2. Okay, another thing that we looked at in terms of log laws is the change of base formula. And again, this is used to evaluate logs with any base. So again, the bases are different and you want to make them the same, again, using the change of base formula. So here, again, log base b of m is equal to log m over log b. And so here, again, if we rewrite this, again, if I write the base there, again, here this base of a can be any base as long as they're equal. So here again, b has to be greater than 0, b cannot be equal to 1, and m has to be greater than 0. So here, if we see this, we have log base 6 of 20. We can rewrite this as log base 10 of 20 over log base 10 of 6. Again, if it's log base 10, we don't have to write anything, so it's log 20 over log 6. Here, you can rewrite this. Again, so log 20 we can split up as log 10 plus log 2. So again, here we have log 10 plus log 2 over log 6. And log 10 is equal to 1. And so that's plus log 2 over log 6. Here, again, it says write log 5 over log 3 as a single logarithm. So again, here, we can rewrite it using, again, that change of base formula. We'll reverse it. That'll be given to us as log base 3 of 5. Okay, so let's look at a couple of examples here. So first example says solve 5 is equal to log base 4 of 15 to the power of x for x, correct to 3 decimal places. So here, first thing we can do here, so we can use the power law. And again, we can bring down the x to the front. So that will be given to us as 5 is equal to x log base 4, 15. Here we can rewrite log base 4, 15 as x log base 15, or sorry, log 15 over log 4. That's using the change of base formula. And so here, if we isolate for x, x will be equal to log, sorry, will be equal to 5 log 4 over log 15. And here it wants 3 decimal places. And so when you put that into your calculator, 5 log 4 over log 15, we'll get an answer of 2.560 approximately. Okay, so let's continue. So here, it says simplify fully and state any restrictions on the variable. So here, if we look at this, we have log square root x over x squared. So the first thing we want to do is we want to look to see if there is any restrictions that occur here. So here we see that, again, square root x over x squared has to be greater than 0. And here, x has to be greater or equal to 0. Okay, and from the bottom of the x squared, x cannot be equal to 0. And so when we look at this, again, we have to find the thing that is the most restrictive in terms of this expression. So the thing that is most restrictive in this expression would be here, x has to be greater than 0. So now we can simplify fully. So again, here if we look at this again, the square root x, x had to be greater or equal to 0. From the bottom, again, x squared cannot be 0, x cannot be 0. And therefore here, when we look at our most restrictive here, x has to be greater than 0. So now we can simplify this. So if we simplify this, we have log, here if we rewrite this, versus x to the power of 1 over 2 divided by x to the power of 2. You can rewrite this here as log x to the power of negative 3 over 2. Move the negative 3 over 2 to the front. So it'll be negative 3 over 2 log x. And here, again, x has to be greater than 0. So if we look at a graph here, and our graph will look something like this. So here we see, again, that x has to be greater than 0. Okay, let's continue on to example B here. So here we have log square bracket square root x to the power of 3. Here, if we're looking at this here, we see that, again, there is a restriction x has to be greater or equal to 0. We look at x squared, and there's no restriction on here. Here, if we rewrite this, then we can rewrite this as log x to the power of 3 over 2 times x to the power of 2 over x to the power of 1 over 2. So again, we wrote that as x to the power of 3 over 2 because it's x to the power of 1 over 2 to the power of 3. So we just use exponent laws there. And so here we can rewrite this as log x to the power of 7 over 2 divided by x to the power of 1 over 2. And that'll simplify as log, again, log x to the power of 3 here we can move the 3 down, give us 3 log x. And here, so we see that here x has to be greater or greater than 0, and therefore our restriction has to be x is greater than 0. In this last example here, we have log x squared plus 2x minus 3 minus log 2x plus 6. So if we look at this first expression here, again, x squared plus 2x minus 3, that has to be, again, greater than 0. And so here, x plus, this can be factored out as x plus 3, x minus 1 has to be greater than 0. And so here, again, we see that this is going to be a quadratic with 2 roots. A quadratic with 2 roots, one at -3 and one at +1. We see that it is positive outside of the roots, and it's negative inside the roots. And so here, again, x has to be less than -3, or x has to be greater than 1. Here, the second thing here, again, 2x plus 6. So here, 2x plus 6 has to be greater than 0. 2x is greater than -6, and x has to be greater than -3. And here, now let's simplify. So here we have log x plus 3, x minus 1 over, if we factor that out, we'll have 2 plus 3, and here we'll be left with, and these x plus 3 will cancel out. So here we'll be left with log x minus 1 over 2. Here, our third restriction. So x minus 1 over 2 has to be greater than 0. Minus 1 has to be greater than 0. And x has to be greater than 1. So here, if we underline our restrictions, or we highlight our restrictions, so can we have oops. So here we have x is less than -3 or x is greater than 1. Second restriction, x has to be greater than -3. X has to be greater than -3. And we have x has to be greater than 1. So we'll see, again, this range, so we draw range here. So we have -3 and 1. So we look at the restrictions. Our first restriction, then x has to be less than -3. X has to be greater than 1. Here we see that. In our second restriction, x has to be greater than -3. And then for our third restriction, x has to be greater than 1. So the point at which all of these are here, or the most restrictive, as we can call it, would be when x is greater than 1. And so that will be our restriction. So here, again, therefore, x has to be greater than 1.